Hello everybody, this is Mr. Graybo. Today we're going to talk about the life cycle of a star. We're going to talk about the different stages that a star goes through in its life, all the way from its birth to its death. And today we're going to focus on low mass stars. So just to recap a little bit, we talked about fusion and how when two smaller elements come together, they make a bigger element, they fuse together, and they release energy in the process, called nuclear fusion. So nuclear fusion is what powers the sun and all stars. And so we have this outward pressure of fusion pushing out, but we also have the enormous power of gravity, that force pushing inwards as well. Now, stars in the universe are all at different stages of their lives, just like people are. And the path that a star takes is going to be dependent on its mass. Okay? And so just like humans go through different stages of their lives, so do stars. Okay, you're going to want to fill in this document. While we do this, you're going to write in the different stages of the star's life, and then you're going to write in some notes alongside of it. Okay, and today we're going to fill out this part right here. So for my class, this document is at the bottom of the learning targets. All right, the first oval that we're going to fill in right up here at the top is called a nebula. This is the birth of a star. Okay, so some information to write down about a nebula. I've put most of the important information, I've underlined it, so you don't have to write down everything, but write down a couple of the key points, especially the things that are underlined. So a nebula, what it is, it's just a cloud of gas and dust that's out in space. It's mostly hydrogen and helium. And due to the force of gravity, these particles are attracted to each other, and they start to contract and come together due to the forces of gravity. Okay, this is a picture of what that might look like. You see everything kind of swirling in towards the center. That's the force of gravity pulling things inward. All right, our second oval is Protostar. And a protostar, what's happening here is as contraction continues, clumps begin to glow. You get a rise in temperature. Things are getting really, really hot. The more massive this thing gets, the hotter it gets. The more it's squeezing inward due to gravity, and it gets hot. It's pressure pushing inwards. So this is going to start to glow. It's not quite a fusing star yet, but it's just beginning to glow because it's getting real hot. Okay, so this is kind of our little baby stage right here. Okay, so here's just another animation of what that might look like. Things are swirling in towards the center. It's getting more and more massive. It's getting hotter and hotter and hotter. Okay, then we get to the main sequence stage. So this is our third oval. Okay, the main sequence stage would be like infancy through adulthood. This is the main thing that's happening here. The main important point here is about the fusion. That's what we're focused on, is the fusion. So what's happening is hydrogen is fusing into helium, and that gives off a lot of outward pressure. Stars spend most of their life in this phase. Here's another key idea here, is that energy from fusion is balanced with the gravity. So the star is not exploding or contracting. It's just balanced. It's in a balance. So in this picture, we see that there's an outward force of fusion pushing outwards. But then what's holding the star together is the force of gravity, causing this star to be kind of in equilibrium. It's not growing or shrinking, it's just kind of staying the same. So some other facts about the main sequence is that the time that it spends burning this hydrogen into helium, this time that it spends there is going to be dependent on its mass. We've learned that large stars burn their fuel much, much faster, and they don't live as long as a small star. So small stars can stay for billions of years in this stage, just because the rate of fusion is much slower. Okay, so now what happens when we run out of hydrogen? Well, what happens when we run out of hydrogen is that gravity is going to start to win and the core is going to contract. The core is going to shrink. Well, when that core shrinks, it's going to increase the pressure, causing the temperature to rise. And when that temperature increases, it allows for helium to now fuse. So now this is kind of like our second fuel source. We burn through our hydrogen, now we're going to burn through our helium. But this new fusion of helium causes a big expansion of the star, and it turns into what we call a red giant. So that is our fourth stage. Okay, this would be compared to like maybe middle-aged person. So a red giant, this is where the fuel runs out, the star expands. It can expand 100 times. Some stars can even expand up to 1,000 times the size. Okay, what happens now is helium is fusing into carbon, nitrogen, and oxygen. And this is kind of the main idea here. Helium is going to fuse to make these next bigger elements like carbon, nitrogen, and oxygen. So these elements are literally formed in the stars. Okay, here's a picture of what this would look like. Here's the sun in its main sequence. Here's the sun as a red giant, much, much bigger. Okay, so during this red giant phase, we're fusing helium to make some bigger elements. So in this size star, we're going to make elements all the way up to about oxygen. Carbon, nitrogen, oxygen. So that's where some of these lower mass elements are formed. All right, now, the path that a star is going to take from this point on is determined by its mass. Low mass stars are going to go one direction, high mass stars are going to go the other direction. We're going to focus on what low mass stars do. So I want you to write this in. Low mass stars are going to go this direction. This is like our sun. Okay, so let's find out what they do. So when all the helium runs out, what's going to happen is these outer layers of gases are going to kind of shed away. They're going to get excreted off of the star, and they're just going to kind of fall off into outer space. This is called the Planetary Nebula. It's got nothing to do with planets, that's just the name. It just creates this big cloud of gas and dust. So here in a planetary nebula, fusion stops. There's no more fusion. This star is starting to die. Here's a couple of pictures of what a planetary nebula looks like. You can see some really cool pictures from the Hubble telescope. It's just these are the outer parts of the star that are getting shed out into outer space. Notice here, you can see that there is a core. That's the core of the star that's left behind. Okay, our next stage is called the white dwarf stage. So if all these gases disperse, what's left over is just the core. That's the white dwarf. So again, fusion is over. The leftover carbon core from the red giant, it's a small, hot white star, and it's just going to continue to glow. Just like if you were to put a big metal poker into a fire and turn it red hot, you take it out of the fire, it's going to continue to glow for a little while. That's what a white dwarf star is. It's the burning hot center of that star that's just continuing to glow. Okay, this is where we hit super old age and we are just about to the star's death. It's not fusing anymore. It's just glowing because it was so hot. The last stage is called the black dwarf. So this superheated ball of carbon that remains in space is going to eventually cool down. So a black dwarf is just a cooled down white dwarf. Doesn't glow anymore. It's just a solid ball of carbon. It might look like a big chunk of charcoal. And we've actually never seen these things. They're just theorized because you can't see a black object in black sky. You won't be able to see one of these. Okay, so this is the path that our sun will take. This is the life cycle of our sun. It will eventually die out into a solid ball of carbon called the black dwarf. All right, guys, we'll talk about the next part, the high mass stars, in the next video. Thanks.